So quickly we'll go through the presentation and we'll complete it IC engine today. And based on that, we'll solve some problems actually. So in this, I think you can be able to see the presentation now.
Yes, sir.
Yes, sir.
So in four-stroke SI engine, we have seen the complete working principle of the SI engine, that is intake, compression, power stroke, and exhaust stroke. In the power stroke only it produces the power, but in the rest three strokes, that is intake, compression, and exhaust stroke, the partially produced power, it is going to be utilized to work the operation. So in CI, in two-stroke SI engine, it is just like our any vehicle uh, which is Yamaha RX 100 is famous for two-stroke SI engine, but it is not being since it is completely disabled from the market. There is no manufacturer yet. So it is working principle is going to be same, except three important things we need to remember here. One is while adding fuel into the system itself, while adding fuel into the engine itself, we used to pour the oil also for the lubrication purpose. So that's why there were no only one piston ring, that is a compression ring. There was no lubricating ring or oil ring, we call it as. In addition to that, yes, the second point, very important point, is that we were not using the valves here, rather than we use ports here. There are three different ports. One is intake port, this is the whatever which you are able to see it here, and the second one is going to be the exhaust port. The another one in the right side, there is a passage which is going to be created from the crankcase to the cylinder. So this is something we call it as a transfer port. So here what will happen actually, in the previous SI engine, that is four-stroke SI engine, the fuel and air mixture was not supposed to enter into the crankcase. That's how the design. But here the fuel and air mixture, which is going to be drawn first, initially it is into the crankcase, and then it will transfer to the cylinder. So this is how the an arrangement, right? So here normally what will happen, in the four stroke, it uses to complete one cycle by four strokes to complete. But here within two stroke itself, from one to from top to bottom and bottom to top, within this two stroke only, it completes one cycle. I mean to say, one revolution of the shaft is going to complete. So here what will happen initially, um, this is something we call it as in this, the first figure in the left side, whatever you will be able to see it, this is in this within, as and when the piston starts moving from top to bottom, it complete two tasks. One is that is expansion stroke, or we call it the power stroke, and the second one is exhaust. So for example, what you can see here is uh, uh, the power which is going to be as and when piston starts moving from top to bottom, one is the power which is going to be liberated. I mean to say, the force is going to be generated very robustly, and the power is going to be produced at the same time. And the piston at the end, as and when the piston uncovers the exhaust port, all the flue gases which is going to be present in the cylinder, which comes out from the cylinder through exhaust manifold, it is going to be exhausted to atmosphere. So it completes power stroke, at the same time uh, exhaust stroke. So this is what happens in this case. The second figure, what you can notice here is, so first now it is at the end, once it reaches, it starts moving from BDC to TDC. As and when it starts moving to TDC to BDC, it uncovers the inlet port. As and when it uncovers, what will happen, the fuel and air mixture which is going to be drawn into the crankcase initially. So as what you can see here, so the piston when starts moving here, a lot of vacuum it is going to be created, and due to this vacuum, the fuel and air mixture which is going to be drawn into the crankcase. So due in this case, as you can see here, so previously whatever the fuel is going to be there, it will start flowing to the cylinder as and when it covers in intake port. But here what you can notice here is, it only draws the fuel and air mixture into the crankcase. Whereas the exhaust port, it is going to be slowly, it is going to be uncovers. So no fuel and air mixture which is going to be drawn into the cylinder. So due to this, what will happen? Due to this, what will happen? It completes. One is when the piston starts moving to TDC, one task, that is compression. Since there will be reduction in volume, that is compression is going to takes place. At the same time, it also takes the fuel and air mixture into the cylinder, into the engine. So it is completing compression stroke and inlet stroke or intake stroke, we call it as. Why? Because it is compressing the fuel and air mixture. At the same time, it is drawing the fuel and air into the crankcase, but it will not allow to the cylinder. It is only entering into the crankcase, but it is not allowing into the cylinder. So this is how, in addition to that, once it reaches to TDC, what will happen? It reaches its certain temperature, that is equivalent to self-ignition, that is equivalent to ignition temperature, we call it as. So as and when it reaches to ignition temperature, the spark plug is produce spark due to the electric operation. So as and when we start, so due to which what will happen, the power is going to be produced further in the figure. So the expansion which takes place, due to the expansion, what will happen, the piston starts moving very rapidly from TDC to PDC, due to which it produces power. At the same time, it also uh, uh, all the flue gases which is going to be exhausted to atmosphere. The very one more important concept here that I have told you, that is the diffuser. So this diffuser normally we didn't find in the four stroke SI engine, because what will happen, because of this construction arrangement. So as you can see here, it is just like in this way. So that what will happen, this design itself, what will happen, uh, as you can see here, the fuel and air mixture which is entering into the cylinder, which is shown with some different color. So this diffuser, it will act that in such a way that the flue gases will push outside through exhaust port. At the same time, it allows the fuel and air mixture, the fresh fuel and air mixture into the cylinder. This will act as a barrier to mix the fuel, and one side it will send out the flue gases or exhaust gases. At the same time, the fuel is going to be entering into the cylinder. It allows the fuel and air going to be enter. So this arrangement, what will happen, this will not allow the fuel and air mixture mix into flue gases. So this helps to avoid mixing of the flue gases with fresh charge. Hope it is clear, friends. So this is what happens in the case of two-stroke SI engine. So we know that two-stroke SI engines, that is Yamaha RX 100 or all that, it produces a lot of it is, since it is going to be since it is being banned, it is no production which is being happening because of the uh, it produces lot of exhaust gases. So as you can notice here in the exhaust manifold, the any EMI vehicle or any two-stroke SI engine, what you find, so there will be a lot of flue gases which is going to be coming out from the exhaust manifold. So that is what we find. So due to which there will be a pollution and all that. Keeping consideration all that, we have stopped producing the two-stroke SI engine. But what is the reason behind this is because the oil is going to be mixed with the fuel, due to which what will happen, the combustion which may not be going to be takes place 100% or completely compared to four stroke SI engine. So due to which what will happen, the unburnt particles of the fuel, that is petrol, is going to be there. So due to this, yeah, it produces gas. So this completes the two-stroke SI engine. So now we'll just move on to the CI engine. CI engine is nothing but diesel cycle, we call it as. So before we move on to that, just we'll go through a PV diagram here. As you can see here, all petrol vehicles, it is going to be operated on auto cycle, we call it as. Auto cycle in the sense, auto cycle, or we call it as a constant volume cycle. So what exactly it is means is that at constant volume, the heat is going to be added to the system, and the heat rejection is also going to be taking place at constant volume only. As you can see here, 2 to 3 and 4 to 1. So the heat addition and heat rejection which is happening at constant volume. And the another one, the compression and the expansion stroke, it is going to be taking place isentropically. Isentropically is nothing but it is adiabatic compression and adiabatic reversible adiabatic compression and reversible adiabatic expansion cycle, we call it as. So what does it exactly means is that there is no irreversibility. So this is going to be an ideal cycle. It is not that the same way it is going to be happen. So actual cycle is going to be different from the ideal cycle, but we assume that it is going to be operated in reversible adiabatic compression and reversible adiabatic expansion process. But whereas the heat addition and heat rejection, it is going to be taking place at constant volume. So this is what the Otto cycle. So now diesel cycle is going to be same as in case of 4-stroke SI engine, what you have studied here. But rather than what one thing is missing is we normally will have the spark plug in SI engine, but in CI engine, that is compression ignition engine, rather than a spark plug, we will going to have a fuel injector. That is something called fuel injector. In addition to this, we'll have lot many devices such as fuel pump. We're going to have, it's going to be playing very important role to pump the fuel into the chamber. But in a 4-stroke SI engine, normally we don't find that. But in CI engine, the fuel injector is going to be having, the fuel pump it is going to have to pump the fuel into the combustion chamber. So the working strokes such as the or the mm, uh, 4 different types of stroke, that is intake, compression, power and exhaust, everything remains, it is going to be same in the 4-stroke diesel engine. But here what will happen, in the absence of spark plug, they will going to use the fuel injector. The inlet and exhaust valve will remain same in both in both SI engine and CI engine. But very important to note here with respect to working principle in CI engine is that, so initially what will happen, the piston will be in the TDC. We know that in SI engine, fuel and fresh charge, that is fuel and air mixed together in the carburetor, we used to draw into the cylinder. But here in what will happen, there will be no carburetor which is going to exist in the CI engine. So simply what will happen, first initially, I'll be just explaining you how actually the CI engine works out. So normally what will happen, the inlet valve is going to be open in the first stroke, the exhaust valve is going to be closed. So only the air from the atmosphere through air filter or through air filter, it is going to be drawn into the cylinder. So there is no fuel which is going to be drawn into cylinder in the intake stroke. That is very, very important in case of CI engine. Only the air is going to be drawn into the cylinder. No fuel is going to be entering into the cylinder. So once the air is going to be entered into the cylinder completely, so what will happen by the end of reaching the piston at BDC, that is bottom dead center, the inlet valve is going to close and exhaust valve remains, it is going to be closed. So due to which what will happen, the piston starts moving to TDC from BDC in the compression stroke, due to which what will happen, the air which is going to be present in this cylinder is going to be compressed. So once it is going to be compressed at the end of compression stroke, or when the piston reaches TDC, both we know that in the compression, inlet and exhaust is going to be closed and the compression happens. So due to this compression, the air which is going to be compressed and it reaches to a very high temperature and pressure. So when it reaches to self-ignition temperature, I am using the word self-ignition. Earlier there was no self-ignition temperature. So here once it reaches to the self-ignition temperature, through fuel injector at the end of compression stroke, that is in the power stroke, what will happen, the compression at the end of compression, that is in the power stroke, the fuel which is going to be drawn or which is going to be sent into the cylinder, it is in the form of jets, fuel jets we call it as, and that is going to be achieving in form of by using the fuel pump. So that is why we use fuel pump here. So to at the end of compression stroke, the fuel which is going to be drawn into the cylinder, which is in the form of fuel jets, using the fuel injector. So it is just like a at very high speed the fuel which is going to be drawn to the cylinder, or which is going to be sent to the cylinder. So it is in the form of jets, or it is in the small droplets kind of it. So due to which the what will happen, the each fuel drops which is going to cover with a very high compressed high temperature air particles which is going to be surrounded with the droplets. The fuel which is going to be drawn to the cylinder in the form of droplets, and each droplets which is going to be covered with us, each molecule of the fuel or each droplet of the fuel which is going to be covered with the air particles in the sense that, and the air particles are which is going to be behaves like a gas, and which is going to be at very high temperature and pressure. So with this what will happen, the combustion of the fuel and air which is going to takes place. So once the combustion starts, there is no spark plug here. You need not to produce spark here with additional device. The air itself, when it reaches self ignition temperature, it starts burning. It will start burning. So due to this burning, due to this burning, it generates a very high force over to the piston. So the piston very rapidly it moves from TDC to PDC, and the power which is going to be produced in the power stroke. Here there is no spark to. You need not to produce. You need not to produce a spark to ignite the fuel. The once the air which is going to be coming into contact with your droplets, as the air which reaches to self ignition temperature itself, it is going to start burning. So due to this, the fuel starts burning, and the force which is going to be generated, and the pistons will starts moving very rapidly. In with this, the power which is going to be produced here. So once the power is produced, the at the end of that is the power which is going to be produced, the piston starts moving from BDC to TDC. Due at this moment, the inlet and exhaust will be closed. As in case of for SI engine, spark ignition engine, all the exhaust is going to be will be taking out through exhaust valve by closing the inlet valve. So the working principle is going to be same, but what is the takeaway from this is that one is the starting problem is going to be very large. It is going to be very large to the extent that is one problem. Second one, we know that why the efficiency which is going to be very low for any CI engine is that because uh, each particle, the fuel particles which is drawing into the chamber may not get sufficient amount of air particles, because earlier in the SI engine, the fuel and air uh, which is going to be in proportion, it is going to be added as per the requirement of the engine. Yeah, that is what we call it as a compression ratio, and fuel air mixture ratio we call it as. So up to that level, it is being going to be mixed properly in the carburetor, and then only it is going to be sent to the cylinder. But here there's a mixing of the fuel and air which is going to be problem. Second one is going to be the ignition delay. Sometimes there will be ignition, though the fuel which enters to the cylinder, there will be a delay in the ignition because it has to ignite by self. It has to ignite by self, but so there will be ignition delay. So all that, because of this all parameter, we will not go into detail, but because of the all these parameters, there will be a problem associated with the CI engine, that is compression ignition engine. So the same thing I have just given in the presentation. In this slide, you can just go through it. Uh, uh, the same thing, like more or less, it is going to be same in the SI engine, but there is no spark plug. Instead, we use fuel injector. Also, we use uh, so with respect to uh, cycle, this is something we call as a diesel cycle. This works on the parameters. Diesel cycle also we call it as constant pressure cycle, since it is invented by or it is going to be invented by a diesel an engine, a scientist. So that is why we call it as a diesel cycle here. So here what will happen, the heat addition heat addition, uh, which is going to be uh, the heat addition which is going to be taking place at constant pressure, as you can notice here. 2 to 3 is a constant pressure. This indicates, straight line indicates it's a constant pressure. Whereas whereas the heat rejection which is going to be taking place at constant volume. So in diesel cycle, the heat addition which is going to be taking place at constant pressure, but heat rejection it is taking place constant volume. The rest of the rest two of the process, that is going to be isotropic compression and isotropic expansion process. So except that, everything it is going to be same. Mm. So now we'll move on to the performance parameter of the IC engine. That is very, very important, uh, uh, because normally what will happen, we know that the engine, the reciprocating motion of the engine, which is going to be converted into rotary motion in the crankcase with the help of by burning the fuel and air in the combustion chamber, due to which the rotation of the shaft which is going to take place, and due to this rotation, a certain amount of torque which is going to be developed. uh, but in order to see the performance of the engine, in order to just to know the engine how exactly it is performing, or to compare the engine performance, we use certain parameters as a reference, or as a benchmark to validate the engine, or to compare the engine, or to see the performance of the AC engine, that are going to be indicated power, brake power, mechanical efficiency, volumetric efficiency, friction power. All that we are going to discuss. And using these parameters, that is performance parameter, we are going to it is not there for your syllabus, but any design or any analysis which is going to be taking place based on these parameter, at the end it is going to be produced the heat balance sheet, how exactly the engine is going to be performed in terms of cylinder, in terms of shaft engine, because there is the whole thing, it is the conversion which is taking place, that is from thermal energy into mechanical energy. So how exactly this conversion is happening, where is the shortfall, where is the shortfall in the power, whether it is in the mechanical or whether it is in the cylinder, whether it is a proper burning. So all that we can be able to see it using these performance parameter. So one by one we'll just look into it. So this will be useful for us to solve the problem. So based on these performance parameter, we can solve problems on this. So the first one is called indicated power. We call it as, it is a indicated power is nothing but, so as we know that there will be a conversion of thermal energy, heat energy into mechanical energy, right? So one is the power which is going to be measured, one is in the cylinder, that is after the combustion which is going to be produced, and one is in the at the end of shaft. So that is something we call it as a mechanical power. So that is at the end of shaft. So whatever the power which you are going to measure by combustion of the fuel within the cylinder, that is called indicated power. in मतलब the जो combustion हो जाएगा cylinder में, उसका जो power, that is why it is we call it as an indicated power. So it is going to be indicated by considering the combustion of the fuel and air mixture. So but during this process, from conversion of thermal to mechanical, there will be some losses we can consider. So normally IP is going to be very high, but we don't get the same power at the end of shaft or in mechanical, because